This is our section on factors and greatest common factors. It's going to be a little bit of a review because we did this in 6th grade and in 7th grade. So first, just a little bit of a review on the definition. Factors are numbers that can be multiplied to get a product. What this means in English are the factors of 12 are 1, 2, 3, 4, 6, and 12, because 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. You get the picture. Prime factorization is when you break down a number into a product of primes, which means you're multiplying those prime numbers together. Remember, prime numbers are numbers that have only two factors, itself and 1. Common primes you'll see are 2, 3, 5, 7, 11, etc. So a couple ways that we might have seen this: factor trees and successive division. So, for example, if you had to do this with 12, you might have done it like this: 6 times 2, 3 times 2, and brought that down and said it was 3 times 2 times 2. Successive division, which is what I'm going to end up doing, is Mrs. Franklin called this the upside down birthday cake. It looks like a ladder, looks like upside down division. So thinking of only dividing by these prime numbers, what's the smallest prime number that goes into 12? That would be 2. 12 divided by 2 is 6. 6 divided by 2 is 3. And then you get 3. And you know you're finished when you end up with that little 1 at the bottom. Some of you may be saying, well, could I have picked 3 to divide by? Sure. You could have done 12 divided by 3 is 4. 2 and 2. And you'll know it's the same thing. It's going to be 2 times 2 times 3, or 2 squared times 3. Same way as if you did it dividing by the 3. And 2, 2, and 3 are all prime numbers. If you divided by 6 to start off with, 6 isn't a prime number, so you don't have prime factorization. So your prime factorization for 12 would be 2 times 2 times 3. I don't mind which way you find the prime factorization. I'm going to do successive division because I find it's going to be easier down the road. The next thing we'll talk about is the greatest common factor, which you know is the largest common number between a pair of numbers, or maybe even with 3 numbers. And you might have done it this way. If you had to find the GCF of 12 and 8, you might have written the factors out and then said, okay, the 1s are the same, the 2s are the same, the 4s are the same, and the 4s are bigger, so it's the 4 is the GCF. You also can find common factors with monomials. So we are going to be moving toward finding common factors with, say, 3x squared and 6x. And what I'm going to be doing is successive division and prime factorization to find these GCFs. So going back to the 12 and the 8, is I would put them together. Do a big upside down division. Again, keeping in mind 2, 3, 5, 7, 11 to start off. 2 goes into both. 12 divided by 2 is 6. 8 divided by 2 is 4. They still have a common factor of 2. And now we're down to here. And there's nothing else common unless it's a 1. So multiply those two together. And that is your GCF of 12 and 8. So let's take a look at finding the GCF of 12 and 60. So I'm going to be thinking again of these numbers. They both can be divided by 2. 12 divided by 2 is 6. 60 divided by 2 is 30. And again, I like to stick with 2's just because they're easy. And then I can go to 3. And now I am realizing that there's nothing else here for the 1 and the 5. So I'm looking on the side, and it's simply 2 times 2 times 3, which is 12. And that's going to be the GCF of 12 and 60. So I'm going to go over to 16 and 48. Divide by 2. Sorry, I'll make that a little neater. 8 and 24. Divide by 2. 4 and 12. Divide by 2. 2 and 6. Divide by 2. 1 and 3. And if I go off to the side, I have 2 times 2 times 2 times 2, which is 16. And the greatest common factor of 16 and 48 is 16. So we're actually going to find the GCF of x squared and x cubed. And I'm going to write it out as if we were just breaking apart these two monomials. So x squared is simply x times x. And x cubed is simply x times x times x. So now thinking back to the what I call the old-fashioned way of finding greatest common factors is, if you notice, this is common. So you have an x there. This is common. We have another x. Therefore, the greatest common factor of x squared and x cubed is x squared. Take a look at x to the 4th and x to the 7th. I'm actually going to put little semicolons here to separate these guys. So we have x to the 4th. There's x to the 4th, x times x times x times x. X to the 7th. Oops, I need another one over here. 1, 2, 3, 4, 5, 6, 7. Okay, so what's common? This one, bring it down. This one, it's also common. That one's common, and that one's common. Well, there's 4 of them. X to the 4th. Let's try one more. I hope you're seeing a pattern here. X to the 3rd. Make that a little neater. And x to the 5th. So what do you think the greatest common factor is of x to the 3rd and x to the 5th? X to the 3rd, there's 3 of them. X to the 5th, where are the common, common, common. X to the 3rd. Did you notice a shortcut here? Let's go and take a look at x squared and x cubed. Hopefully you noticed that your GCF is the smallest exponent value on each of them. This will come in handy when we start dealing with some bigger monomials. So you can look at 9x squared and 63x cubed. You can go ahead and just pull out the 9 and the 63 and figure out what the GCF would be here. So here it's 9, and then you can take the x squared and the x cubed, 1, 2, and it's going to be 9x squared will be your GCF. So if you're just going to look at these, take apart, break them apart, do the 99 and the 63, just like we were doing, and then find the GCF of the x squared and the x cubed. Last practice one here. Go ahead and find the GCF of 12 and 8, which we've done before. At some point you won't have to write all these out. So we know that it's 4. If you can remember the shortcut, you have x cubed and x. Remember, there's a 1 here. So you're going to go with the smallest exponent value, which is x. Now we have the b and the b squared. That's got a 1. And that one's going to be the smallest. So your GCF will be 4xb. Let's try one more of these types. Okay, so we have 3x squared y cubed and 15x cubed y squared. So looking at the 3 and the 15, the GCF is 3. Looking at the x squared and the x, we're going to go with the smallest exponent value. But what happens if it's the same? Well, if it's the same, just think of it this way. There's one y cubed and there's the other. It's going to be y cubed because they're all a match. 3x squared y cubed. Now on the last page, we're going to take a look at what happens if you have three terms together. Okay, if you had to find the GCF of three terms, you have 12, 8, and 6. So we're going to, again, what number goes into all three? And that's 2. 12 divided by 2 is 6. 8 divided by 2 is 4. 6 divided by 2 is 3. And you have a 6, a 4, and a 3. There's no other number that can go into all three of these. So your GCF is simply going to be 2. Equals 2. Let's try the GCF of 12, 18, and 36. They all can be divided by 2. And now we have 6, 9, and 18. Those can be all divided by 3. And this is where we run into our problems. All three of those can't be divided by the same number. So your GCF is just 6. Check the website for homework, if there's any.